So today we're going to start talking about certain values of an exponential function. Now, exponential functions usually look like this. F of x equals a times b to the x, where a and b are both numbers, and then x represents the independent variable, the thing that's going to be changing. So depending on the value of a and the value of b, the function will look differently because both of these values have a certain effect on the function. So today we're just going to identify the role of a and its connection to the y-intercept in the exponential function f of x equals a times b to the x power. So in this function, a and b both have very specific roles that alter the pattern of the function. The variable a represents the initial value of the function, or you could think of that as the starting place. If you think of an exponential function as something that's actually happening in the world, for example, how we folded papers on the Friday before break, and our papers started with one layer, that would be the initial value, the starting place, the starting value that we have. That is what a is. So this is really just, if you think about the graph of the function, if you're just looking at the first quadrant there, when the time or when, after 0 times is being multiplied, it would just be the a value is just the initial value. So it's almost like it is the y-intercept. So using what we already know about the y-intercept, we know that the y-intercept happens when x is 0 because each intercept happens when the other value is 0. So in this first function, this exponential function represented by this table, the value of a can be found by looking at the y-intercept. So in this one, a would equal 1 because the y-intercept is 1. When x is 0, y is 1. In the next exponential function or table represented by an exponential function represented by a table, the y-intercept or the initial value is 3. So the value of a is 3. In this last one, the value of a is 1/2 because a is the initial value, the starting place, which is the y-intercept. Now if you look at these, now we're really just looking at the graph and identifying the y-intercept. Remember that this is the y-axis, and our function intersects the y-axis here at 2 because this is counting by 2s. 2, 4, 6, 8, and so on. So here is 2, so the value of a would be 2. That's the y-intercept. Here, this table is kind of hard to read, but it's going 1, 2, 3, 4, 5, 6, 7, 8. So this is at 1 right there, is where it's crossing the y-axis. This one is crossing, it looks like at 3 because each unit is counting by 2. So 2, 4, it's right in the middle of 2 and 4, so a would be 3. Okay, so a is the initial value, the starting place, or really we can think of that mathematically as the y-intercept. And that's all for A.